So in this video, I'm going to go over the quiz 8. So the overall percentage on the quiz was a 59. So if you did better or worse than that, that kind of tells you where the whole group of geometry students did. So version B, remember this is version A, 1 and 2, but if you have version B, it's 7 and 6, okay? So those are our percentages on those two questions, 57.8% on number 1 and 48.3%. So we're going to actually talk through how to do these problems. Okay, so the first one says what parts need to be congruent to prove that yxw is congruent with yjk by hypotenuse length. Key here, right? So we need to know, first of all, that it's two right angles, right? That's another right angle because they are vertical angles, okay? Then notice that we have that xy is congruent with jy, right? And that is a leg, yes? Okay. So that means we need the hypotenuse, right? So what we have is a leg, what we need is a hypotenuse. Remember, the hypotenuse is opposite the right angle, opposite the right angle. So this is the side that we need, okay? And that is side xw. And let's see where xw maps to. Xw maps to what? jk. See that right there? Which is why the answer is xw is congruent to jk. All right, then the next one says a rectangle is 3.2 centimeters wide and 8 centimeters long. A similar rectangle could be 32 centimeters long and blank centimeters wide. So this is what I'm going to do first. I'm going to talk about how to set this up. I'm going to do wide over long, okay? So that means that I'm going to do 3.2 over 8, right? And that's going to be equal to a similar rectangle could be 32 centimeters long. So that 32 goes to the bottom, and this is probably the mistake that most of y'all made. And then we're looking for what? We're looking for the width, right? Isn't that what we're looking for? So we're going to cross multiply, so that's going to be 8x is equal to 3.2 times 32. And when we do 3.2 times 32, we get 8x is equal to 102.4. Then we're going to divide both sides by 8. So x was equal to 12.8 centimeters, right? So once again, if you had version B, that was number 6, okay? So 3 and 4 for version A, 8 and 5 for version B. Double check and see how you guys got on, how you did on these questions, okay? So now on this one, number 3 says a parallelogram RSTU. ST is, okay, so in RU, we got ST and RU. These are opposite sides. So everybody should know that ST is equal to RU, yes? Opposite sides are congruent, so we can use that to solve for x. And then it's asking us about SC and UC. Well, SC is a diagonal, part of a diagonal, and UC is part of a diagonal. Remember, the diagonals do what to each other? So for the green part here, we have that opposite sides, actually let's do it in the same color. Opposite sides are congruent, right? So opposite sides are, we'll just say equal. How about that? And then you should know that diagonals bisect each other, so we're going to write diagonals bisect each other. Okay, so what does that mean? So that means ultimately that SC is going to be equal to UC, right? Okay, so let's just go ahead and solve for the x first then. We're going to do 5x plus 8 is equal to 3x plus 14. I'm going to subtract 3x from both sides. So now I got 2x over here, and now all my 3x's are gone. I'm also going to subtract my 8, because remember I got to get the variables on one side and the constants on the other. So subtract 8 from both sides, so now the 8's are gone, and that's equal to 6, so x is equal to 3. Now that's not my answer, because we have to take that 3 and plug it back in, and we know that SC is equal to UC, so we can just solve for SC, right? So that's what we're going to do. So SC is equal to, so we'll just say UC is equal to, right? So UC is equal to, okay, my pen is going crazy again, y'all. So, sorry. So we're going to go 3 times our 3, which is our x, plus 5. So that's 9 plus 5. So that means UC is equal to 14, knowing that SC and UC are equal to each other, right? So that's why the answer was 14. All right, then it says UVW is similar to USR. What is the measure of UR? So what we want to do here is we want to see some sides that we can compare with one another. So if we're looking for UR, UR's first last, right? So I'm going to look at what does it map to on the left. UW, right? So I'm going to say UW over UR. And so I'm going to go left over right. The left triangle over the right triangle, okay? And we're going to keep it that way throughout the problem. Okay, so then that's what we're looking for. And what else do we have? Don't we have UV? So, or VU, we can say VU is what? What does VU map to? VU maps to SU, right? Okay, so that's what we're going to do. That's how we're going to set this problem up, okay? So now we're just going to look and see what those measures are. UW is right here, so that's 63. And we're looking for UR, remember. And then we got VU is 90. It's right there. Right there's VU, so that's 90 over what? What do we have? It's SU, right? So SU's right here. So that's going to be 50. So we just cross multiply again. You remember this? Do this. So that's going to give us 90 UR, and that's going to be equal to 63 times 50, right? So 90 UR, what is 63 times 50? That's 3150, right? So 3150, and then we're going to divide both sides by 90, right? So UR is going to be equal to 35. And we can check this. Remember how? Okay, let me show you guys. So you can put that 35 right here. Let me put it in red. Push the button, maybe. 35 right there. So we want to compare 63 over 35. 63 divided by 35. Turn on things. 63 divided by 35 is equal to 1.8. And we want to see if that's the same ratio here, right? 90 divided by 50. Go ahead and divide that, and that is also 1.8. So that's how we check our answers, y'all. Do we get the same value when we create the ratio? All right, number 5, and then on version B it's number 10, and 6 on version A, and for version B it's number 3, okay? So we go again. And this is a question that we got 37.1% on, okay? I was very disappointed in this, as were all the other teachers. So it says, given that JKLM is a rhombus, okay? Did you notice those words? So what do we know about a rhombus? We know that all the sides are congruent, right? We also know that the diagonals bisect each other, right? Okay, but that's not any of the information that was given to us in the problem. So that's really not relevant to us at all. But we also know what? What do the diagonals do to the angles? Diagonals, we're going to write this. Diagonals bisect opposite angles. And we also know another piece about angles, right? We know that opposite angles are congruent, right? Opposite angles are congruent. Okay, so we're going to use those two pieces of information to solve this problem. So we have that KLN, that's that angle right there, this angle, is 40, which means the angle beside it down here, MLN, this angle right here is also 40. So what is all of angle L? That whole angle right there would be 80, wouldn't it? Because 40 plus 40 is 80. Okay, let's go on with the other piece of information that we're given. JMN, that's this angle right here, is 50. Right? Which means this angle right here is 50. Which means this whole angle is 100, right? Which makes sense because the angle beside it is 80, and when we add 100 to 80, we get 180. And those consecutive angles should be supplementary, right? But then the question asks us, what is the measure of JKL? It's asking us for that whole angle right there, y'all, the whole thing. This whole angle right here. And what do we know about opposite angles? You got it, they're congruent. So the answer was 100. Now, many people chose 90, and I'm guessing the reason people chose 90 is because that was the answer to the question that was like this on the last quiz. But these are the angles that are 90, not the ones that we just did, okay? So you got to read questions, guys, to get questions correct. So number 6 says ABC is dilated by dxy 1.5x. So this is our scale factor. is what? 1.5, right? 1.5. So we're going to multiply 1.5 times the measures of C. So here's our C. So we're going to go 1.5 times -2. That gives us -3. And we're going to do 1.5 times -1. That gives us -1.5. That's why our answer is D. Okay, on the next one. So again, we're talking about version B is 9. This is 7. This is version A, and 8 on version A. So B is 9 and 1, okay? So A, D, B, E, and C, F are medians of triangle ABC. It says GC is 36. So GC is this measure right here, right? 36. So we have the big part of the median. So how do we get the small part of the median? So we get FG by dividing GC by 2, right? So we're going to do 36 divided by 2. That's going to give us 18 for FG, sorry. So we can put that 18 there. And then what do we know about CF? CF is going to be FG plus GC, right? So we're going to add the 18 to the 36. And that's going to give CF is going to be equal to 54. All right, find the scale factor of the dilated triangle. Okay, so now remember what we're going to do with this is we're going to take our A prime, or our prime, whatever that is. We're going to just do A prime over A, right? So we're going to take where we ended over where we began. So we're going to take end over begin, okay? Or we could say what? Image over pre-image, okay? Another way to say it. So let's just look at these values now. Our image is what we ended with, right? So let's just do A, okay? So this is going to be 3, and we'll do the 1 over here, and we're going to divide that by what we started with, which was our 6 and our 2. So that was our A prime, right? And this is our A. So either way, what do we get with both of those, y'all? We get 1/2, don't we? Okay? That's how we get it. All right, given RT and SU are perpendicular, that means that there's another right angle right there, right? And that SUR is this angle right here. And RUV is this angle right here. Those angles are congruent, it says. If the measure of angle R is 28, that's this angle right here. If this is 28, find the measure of angle T. So we're actually looking for this angle over here, but we got to find what the third angle is in the triangle on the right first, right? So the red arc, that's what we're looking for. So hopefully you know that if 90 was used, then we can just take 90 and subtract 28 from it. And when we do that, we're going to get 62, right? So that means this angle right here is 62, and if the other one's congruent, it's also 62, right? So now hopefully you can see that these angles form a straight line. Y'all see that? What's the measure of a straight line? 180, right? So we're going to say 180 minus 62 plus 62, right? So that's going to be 124. So that's 180 minus 124. That's going to give us the angle in blue right here, that angle, right? Got to find that to find the question mark. So 180 minus 124 is 56. So now we know that this angle right here is 56. We're going to use the same process we used to find the 62. We are going to subtract 90 minus the 56, and that's going to give us 34 degrees for our missing angle right here. This angle right here is 34 degrees. And how do I know that? Because 34 plus 56 plus 90 is, guess what? 180. Okay? So we did very poorly on this question. I'm assuming it's because it was so many steps, okay? So then version B, number 2, and version A, number 10. So this was, we did 65.2% on this question. So on this, it should have said EF here, y'all, okay? EF is a midsegment of BCD, and or FE, doesn't really matter how it was stated, got it? But hopefully you know that two of these appear here, right? So this would be the same length as FE, and so would this. Y'all see it? So 2 times FE is equal to DB, isn't it? Okay, so that's how we're going to actually do this problem. So we're going to go 2 times our x plus 19, and we're going to set that equal to our x plus 29. So that's 2x plus 38 equals x plus 29. We're going to subtract x from both sides. So that gives us x over here, and now x's are gone. We're going to subtract 38 from both sides. And that's going to be equal to negative 9. Okay, so that 38's gone from there. So now that could be perplexing, right? Because we think when we get a negative, then it's wrong, but it's actually asking us to find EF. Okay, so EF is what? Equal to negative 9 plus 19. That's 19 minus 9, so that's just 10, right? Now listen, that's our answer, yes, but the way we check our answer is we plug that also into BD. And that should be 20, right? So this would be negative 9 plus 29, which actually is 20. So that's the way we can check our answer. If this times 2 equals that, then we know we got the correct answer. So our final question, our bonus, was, and it said no drawing, no credit. So if you didn't do a drawing, you didn't get credit for this problem. It said UVWX is a parallelogram and the diagonals intersect at Y. So UVWX, these have to go in order, y'all. And if you drew it another way, which some of y'all did, then that's why you probably got it wrong. And then it says that the diagonals intersect at Y, okay? And then it says given the measure of x, WXV, WXV is 17. So that means this angle up here is also 17, right? And then it says WVX is 29, which means this is also 29. Now those angles are congruent. Why? Because they are alternate interior angles, right? So these angles are congruent. These angles are congruent again because they're alternate interior angles, okay? Then it says WUV is 64, okay? So if this angle up here is 64, then this angle down here is 64, yes? Okay. Now, let's add this 17 to the 29 and let's find out what this angle up here is, this angle, okay? So that would be 17 plus 29 is 46, right? So this is 46 up here. That means this is 46 down here because opposite angles are congruent, right? And we would subtract 180 minus 46 up here to get this one. So this angle is going to be 134 degrees, which means its opposite angle is going to be 134 degrees. Now, how would we find this angle right here? We would subtract 64 from 134. So this angle right here would be 70, which means this angle down here has to be 70 because, again, they're alternate interior angles, okay? So now we have that opposite sides are congruent. So if this is 24 over here, this has to be 24, right? And then we had our 41 down here. And so 41 up here, opposite sides are congruent again. Remember, what do diagonals do to each other? So if this is 15 right here, then this has to be 15 right here. And the whole length has to be 30 of the diagonal, yes. This part of the diagonal up here is 40. So this part down here has to be 40. So the whole diagonal has to be 80. So then when we're looking at angles, UVX, I'm going to draw it in black, y'all. UVX is this angle right here, UVX. So that's why it's 17. WXU is the whole angle over here. WXU was 46, and we had to add those two parts to get it. That's why it was 46. XUV is this angle up here, XUV, right? So it's all of that, 134. And then we've got VWU, so that's this angle here, VWU is that angle right there. VWU was 70, y'all. So that should have been 70. Then we have XWV. XWV was the 134, so that's right. 134. And then we do have our opposite sides, 24 here, and then we have the diagonal, which would have been all of this, 15 plus 15, YX, where's YX? Yeah, YX is here. Let me do it in red. YX is here. Oh, red. yx is there, xy, same thing. That's 40, and then we had the whole thing, which would be 40 plus 40, right? So that's 80. And then we have uv, which is 41, because it was the opposite side, okay?